All right, here we are, page 3 of triangles. Now I don't have to draw anything anymore, so this should be a little bit easier for us as we go along. So classify each triangle. Isosceles, how many sides are equal? 2, right? Scaling, none are equal, right? And then equilateral, it's got the word equal in it, right? Equilateral, so we know that all of the sides are equal. We've got acute, which means all of the angles are less than 90, okay? We've got obtuse, which means only one of my angles is greater than 90, because that's as many as you could possibly have. And then I've got right, it's only got one right angle, because that's as many as you could possibly have, all right? So, let's take a look at the first one. We'll go by length of sides, and then we'll write the angle. So if I look at this, I've got 11, 12, and 14. If it's 11, 12, and 14, are those all the same, all different, couple the same, all different, right? So that's going to be scaling. And if I look at my angles, I see 75, 54, and 51. Any of those 90 or more? Nope. So that's got to be acute, right? It's a cute little scaling. All right, look at this one. What do you think about this one? Remember when it has the lines through there, that means all of those are the same length, right? So that's going to be equilateral, right? And if it's equilateral, it's going to always have acute angles, and they're all going to be 60 degrees. So this is equilateral acute. You cannot have an equilateral triangle that is not acute. All right. And of course, look at this one. How many sides are the same? 2. So that's isosceles, right? That's a really hard word to spell. All right. And is it acute or obtuse? Well, I can look at it. I can deduce that if I subtract 29 from 180, I'm going to get 151, and half of that is 75.5, which is less than 90, so I know that it's acute. Or I can also take my paper, and if I put it right here at the vertice, right, this goes underneath. That makes it acute. It would have to be outside of this to be obtuse, which it is not. So it is, it's a cute little isosceles. Okay, so on your own, once you give these a try on your own, pause, and then come back and see if we agree. All right, so you're back. So this one, they don't even draw you a picture. You just got to look at it. I've got 3.5, 6.2, and 3.5. So I'm going to, anytime I see something like this, I'm going to go, oh, okay, well, there's a 3.5 and there's a 3.5. There's 2 of them. That makes it a what? Isosceles. I hope you got isosceles. And then I look at my angles, and I'm only going to look and see if there's a 90 or something bigger than 90. Is there something bigger than 90 here? There is, right? 126. That is obtuse, right? So I get isosceles obtuse. If I get 2, 5, and 3.8 inches, any of those the same? Right? So that's going to be that scaly one, right? So scaline. Nothing is the same. And then I look at my angles. Is there anything larger than 90 or 90? Yes, 116. So that means obtuse. Easy peasy. Circle the figure that does not belong. So which figure does not belong? You can look at this a couple of different ways. For me, I'm going to say that it's this one. Because these two are right triangles, right? So the one in the middle is not a right triangle. I'm gonna have to squeeze it in here. You know, and you could look at this a couple of different ways. You could say that this one doesn't belong because it has no equal sides, while this one has at least one pair of equal sides. You could look at it that way. But this seems to me to be the most obvious, all right? That these are right triangles and that one's not. Okay, so up to you. Draw 2 equilateral triangles that are congruent and share a side. What polygon is formed? Is it regular? Okay, so remember, every equilateral triangle is a regular polygon. So I'm gonna try to draw two of these things next to each other. So let me see if I do it like this. Okay, so just draw a small triangle like that. And then since they're sharing a side, I'm gonna just go down and down. All right, so when I take this little piece out of the middle, all right, so what shape is that? It's a diamond, but we're gonna call that a quadrilateral. So we get a quadrilateral. How many sides in a quadrilateral? 4, right? So now we've got a 4-sided shape. And is it regular anymore? It's not going to be regular anymore. I used to have a 60-degree angle here, but now I've got two 60s, right? Okay, so that's not going to be regular anymore. Not regular. All right, easy peasy. Last page coming up.